Number 22, we just see how many are where my extra j's are. There's extra j's on top, and there are 3 of them, so you could put j to the third on top. There's extra k's on bottom, and there are 8 of them, so it's k to the 8 on bottom. Number 23, to graph the equation, you can use your x and y intercepts, and that will work just fine. Most people will probably want to solve for y, so I'll do it this way. I end up with 6y equals 5x minus 30, divide by 6, and I end up with y equals 5 over 6x minus 5, with a slope of 5 over 6 and a y-intercept of negative 5. And I just plot 1, 2, 3, 4, 5 on the y-axis, and then go up 5 to the right 6. 1, 2, 3, 4, 5, 6. And I don't have room to go any farther, so I will take my line, extend it through my points, and draw arrows at the end. The next one, simplify the sum. Well, I see the distributive property. There's a 1 in front and a 1 in front. When you distribute, it really doesn't change anything in this case, so I get 6u cubed plus 3u squared plus 5. And then when I distribute this one through, I get plus 4u cubed minus 4u plus 5. Then write my answer in standard form, highest exponent to lowest exponent. I get 10u to the third. There's nothing else like the 3u squared, so I bring it down. There's nothing else like the negative 4u. And then I add a 5 plus 5, and I get a plus 10. Number 25, I distribute a positive 1 through this set of parentheses and a negative 1 throughout this set of parentheses. This gives me a negative 7x minus 5x to the fourth plus 5 plus 7x to the fourth plus 5 plus 9x. Start with the highest exponent. Negative 5x to the fourth plus 7x to the fourth is 2x to the fourth. Then I have negative 7x plus 9x, which is plus 2x. And 5 and 5 give me a positive 10. For number 26, this C right here should have been an A, so change it to an A before you start working. And then distribute, and remember, when you're multiplying, you add your exponents. So negative 2 times 3 is a negative 6, and then we keep our base and add our exponents, so it's a to the 9th. Negative 2 times 8 is negative 16. I add our exponents, and I get a to the third. Negative 2 times 1 is negative 2a to the second. 27, this is one of your special lines. It is a horizontal line. You go to negative 4 on the y-axis. You can only touch the y-axis, so we know that it is a horizontal line. 28, what is the vertex? The vertex is right here, and so we get a vertex of 0, 1, and because it is a low point, this is considered a minimum. Somehow I skipped from 28 to 30. What is the solution? Use a graph. Well, when I graph this, I start at negative 4, 1, 2, 3, 4. I rise 3, run 1, rise 3, run 1. And then I draw my line, draw my arrows, and now I'm going to graph the second one. Start at positive 2, rise 3, run 1, rise 3, run 1, go in the other direction, and extend your line. Hopefully you can see that they're parallel, and you can also tell by their slopes that they're going to be parallel, same slope, different y-intercept. So these are parallel, and they do not intersect at all, and when they do not intersect, the answer is no solution. There's no way, nothing that they have in common. 31, what is the solution? It says to use substitution. So you're going to take this, and you're going to substitute it in for y in the top equation. So 3x plus 2 parentheses instead of the y, we're plugging in the box. And then we still have our equals 7. 3x minus 6x plus 22 equals 7. Combine your like terms. Negative 3x plus 22 equals 7. Subtract 22. Negative 3x equals negative 15. Divide by negative 3. And I get x to equal a positive 5. For number 32, you need to create a table for this, if you don't have a graphing calculator especially. And so when you create a table, you need to plug in negative 3 all the way to positive 3. So when I plug in negative 3, I get a third, or 0.333. When I plug in negative 2, I get 1. When I plug in negative 1, I get 3. 0 produces 9. 1 produces 27. 2 produces 81. And 3 produces a really big number off the graph. So I graph negative 3.333, which is barely off of 0. Negative 2, comma 1. Negative 1, comma 3. 0, comma 9. That one's off the graph a little bit. And if I try to do 127, it's going to be way on up here. And so hopefully you can see the general shape of this exponential function. So just kind of extend it a little bit. GCF between 39 and 33 is a 3. And then you look at how many x's they have in common: x to the fourth, x to the third, x to the second. The lowest is x to the second. So your GCF is a 3x to the second. For 34, you can either use FOIL, you can use the distributive property, or you can use the Punnett square. 4h plus 2, 5h minus 7. This gives you 20h squared, 10h, negative 28h, and negative 14. Combine your like terms. You can't really read that all that well, but you end up with 20h squared minus 18h minus 14. 35, what is the factored form? Well, I noticed right away that there's a GCF of a 2. So I need to pull the 2 out by dividing each term by 2. And I end up with 2 parentheses 3g squared plus 4g minus 4. And then this is the thing that I need to factor. So I multiply 3 and negative 4 and get negative 12. And they have to add or subtract a 4. And the two numbers that do it are 6 and negative 2. So I do my Punnett square. And I really don't do anything with that outside 2. It's just going to be a tag along. So nothing happens there. But my first term is 3g squared. My last term is negative 4. And my middle two terms are 6g and negative 2g. GCF is g. GCF is 2. GCF is 3g. GCF is negative 2. So you end up with g plus 2 times 3g minus 2. And you can't forget about that GCF of a 2 right here. And this is your final answer. 36, what are the solutions? I see x squared minus 4 equals 0. I see it's a binomial, so I can add this 4 over. And I end up with x squared equals 4. To undo squaring, I take the square root. I should have two answers. X equals positive 2 or negative 2, which means that I go over to positive 2 on the x-axis and negative 2 on the x-axis. And I know this opens up because this x squared is positive and the vertex is in the middle. And I'm just going to go ahead and tell you the vertex is at 0, negative 4. But you don't have to know that. You just have to be able to find the solutions. And as long as you can find this part right here and you know that where they are on the graph, you don't have to stress out about the vertex. 37, zero product property. 4x minus 12 equals 0. 3x minus 1 equals 0. You solve by adding 12. 4x is 12, divide by 4. You end up with x equals 3 as one of your solutions. The other one, you add 1, divide by 3, and you end up with x equals a third. So you should have gotten x equals 3 and x equals a third as both of your answers. For number 38, what are the solutions? Well, you see it's already set equal to 0, so we go straight into our multiply and add or subtract table. They have to multiply to negative 24 and add to 5 and 8 and negative 3 do it. Some of you are going to realize the coefficient of 1, so you can go straight into your x plus 8 and x minus 3 equals 0. Some of you are not, and if you don't, it's okay. This is where you would do the Punnett square, and you'd use the first term as z squared, the last term is negative 24, the middle terms are 8z and negative 3z. Then you pull out a GCF of a z, GCF of an 8, GCF of a z, GCF of a negative 3. And no matter what, this should have been a z, not an x. But no matter what, you end up with z plus 8 times z minus 3 equals 0. So z plus 8 equals 0, z minus 3 equals 0, and you subtract 8. Z equals negative 8, add 3, z equals 3, and those are your two solutions.